This is my project on EEGs, also known as electroencephalograms. The main equipments of EEG are electrodes, wires, and conductive gel. Electrodes are inserted on the scalp to pick up brain activity. Wires are used as conduits that transmit brain activity from the electrodes to the amplifier. Conductive gel is highly optional, but it helps with improving the signal of the electrical activity. This procedure is non-invasive, which means that there is no surgery required. EEG records electrical activity in the brain even when we're asleep. The electrodes have to be in a certain arrangement for the EEG to work. Electrical activity is displayed as oscillations. Since the movement of brain activity is pretty predictable, EEG is used to read event-related potentials, which are small voltages generated in the brain structures in response to different stimuli. This can range from looking at a deaf person's ERP compared to a control group, or just looking at someone's ERP after hearing certain words in a sentence. EEG can also be used for detecting seizures. It can display any abnormality in brain activity. EEG has a high temporal resolution but low spatial resolution. Since EEG has a high temporal resolution, it allows it to record brain activity with acute precision, with changes occurring as fast as a millisecond. However, EEG has poor spatial resolution, which means that it cannot pinpoint specific neurons responsible for certain brain activities. One advantage of EEG compared to other techniques is that the effects of neural stimulation can be seen immediately. Like I said before, EEG has a good temporal resolution and can measure activity within milliseconds, while other techniques such as fMRIs and fNIRS observe changes within seconds. Another advantage of EEG is that it's relatively cost-effective compared to other techniques such as fMRI. A single patient can cost up to $800 using that technique, but with EEG, it costs $1 to $3 per person. One disadvantage about this technique is that it's difficult to pinpoint where the brain activity occurs. For example, MEG has a better spatial resolution compared to EEG because magnetic fields are less distorted by skull and scalp. Another disadvantage of EEG is that it can only provide information about surface cortical sites, but other techniques such as fMRI can go deeper in the cortex. Despite the disadvantages that EEG presents, its benefits are really conducive towards sleep studies, epilepsy studies, and speech and language research due to the high temporal resolution of this technique.